Hi, good morning to all of you. My name is Dipjyoti Das. You can call me Deep. I work as a data scientist, and today I'm going to talk about an unsupervised machine learning approach called Gaussian Mixture model and how it can be used to target and segment energy efficiency program leads. This is the agenda. I'm going to introduce myself. Then I'm going to talk about the business problem and the value proposition. I'm going to talk a little bit about the data preparation and engineering part. Then I'm going to talk more about the machine learning model called the Gaussian Mixture model. I'm going to visualize a couple of plots and results from this model, and then I'm going to summarize everything that I discussed today. So who am I? I work as a data scientist at Duke Energy. Duke Energy is one of the largest power holding companies in the US, and it generates and provides electricity to around 8 million retail customers, and it has a portfolio of renewable energy assets and natural gas distribution services. I have overall close to 8 years of experience in the data science field, and I have worked across various business verticals: marketing, sales, product distribution, operations, etc. I have also worked in different companies: financial services, insurance, logistics, and automotive industry. Apart from work, I am also involved with Great Learning, which is an educational technology startup, and they have partnered with UT Austin. I teach and mentor an AI ML course to a cohort of around 20 experienced working professionals who want to upskill in the field of machine learning. I am also involved with a few local AI and ML meetup groups, and I graduated from University of Florida. So the business problem is Duke Energy wants to sell energy efficiency program to non-native Duke territories. Now, in US, some of the states especially where I reside, they have regulated market, meaning customers have only one choice or one option to get energy from. Now, there are few states like Texas, Ohio, where it is a deregulated market, meaning customers have more than one option to choose the energy provider. Now, in a regulated market where Duke provides energy, they are called native territories, and we know a lot of information about those customers, like their billing history, how long they have been with service, etc. For non-native for non-native territories where Duke doesn't sell any energy, we do not know much information about those customers. Now, if we see a market report from Advanced Energy Now, this was back in 2017, we see the total US building efficiency revenue across different segments, whether it is building design, HVAC, water heating, lighting, etc., is close to around $69 billion. In my current work, Duke Energy wants to sell programs related to HVAC and lighting, and that amounts to around $42 billion. So there is a business case where Duke Energy wants to acquire new customers in their non-native territory. And to achieve that, we have a team called Biz Market Team, and there are business energy advisors who, based on their knowledge and experience on the field, they try to gain this non-native customers, and they try to acquire non-residential property owners because they are the ones who use and consume more energy per kilowatt hour basis. And over a period of 3 months, they have been able to find around 40 leads, 40, and that is based on their experience and knowledge on the field. Now, I work in the data science solution team, so what I want to employ is a more data-driven approach, and my goal is to increase the incremental revenue to tens of millions of dollars, and to use a machine learning model to provide more effective leads to the marketing team. The workflow and platform that I used for this work is from Microsoft Azure. We have a close partnership with Microsoft, and I use Azure Databricks. They have other components like Apache Spark and MLflow. Apache Spark is used to build the data engineering data pipelines, and MLflow we can use to test and deploy the models. So all the data that is used for this work, it has been acquired from third-party sources. So the primary data source that I use is from CoStar. Now CoStar is very similar to Zillow or Realtor.com. Now if you go to Zillow, you see they collect different attributes and information about single family homes, like number of bedrooms it has, how big is the area, where it is located, etc. etc. Similarly, CoStar collects information about different properties and buildings, like the total rentable building area of that property, how many tenants can reside in that property, how many parking spaces it has, the total number of floors in that area. So they have around close to 200 to 220 features. Apart from CoStar, I also use macroeconomic indicators, and these are on a zip code level basis, like the median household income on a particular zip code, number of households earning more than $200,000 on a zip code, what is the employment and unemployment percentage on a zip code level basis. So these are macroeconomic indicators. The data preparation is done using some techniques. I'm going to talk a little bit about the next slide. I use Azure Maps API to normalize few addresses. Then I do some data imputation techniques to impute some missing values. The model is built using an unsupervised machine learning model called Gaussian Mixture model, and later the model can be deployed using MLflow, etc. And we can provide a ranked scored list to marketing team, and they can effectively target and segment the population. The data preparation and the data engineering part, I'm not going to go too much into the details. As I said, I use Azure Map Geospatial API to standardize certain addresses, because most of the addresses that we get from third-party sources are not clean, so we need to normalize them. I use few imputation algorithms to impute the missing values using certain assumptions. Here I have shown how the total taxes variable, how the distribution is before imputation and after the imputation is done based on our assumptions, and I use soft impute algorithm to do so. Now this is the model development process. So first of all, we need to discuss why do we need an unsupervised machine learning approach. So one of the challenge for this business problem is the business energy advisors have provided us to a lead count of around 40 in number, who have signed some kind of an agreement and contract with Duke Energy that they are interested to buy energy efficiency programs. But we actually do not know customers who might not be interested in our programs. So there are no true zeros to build a classification model. So that is why we thought a better approach is to build through an unsupervised machine learning model. And here I have shown two plots, the left and right. Now k-means clustering is a popular unsupervised machine learning model. So in a k-means clustering, what happens is that it gives a hard cluster assignment, meaning every data in the distribution is given a cluster number. But if your data distribution is not good, what it can happen is that a point can be in multiple different clusters, because the clusters that are drawn in k-means are circular shaped boundaries, and it can overlap between multiple clusters. So this problem is fixed if we use a Gaussian mixture model, because in Gaussian mixture model every data point is given a probabilistic value to be in a particular cluster. Now the clusters are learned by using any shapes, so even if the distribution of data is not good, we can draw many different shapes to find out what is the probability of a certain point to be in a particular cluster. And that is why we use Gaussian mixture model in this problem statement. Now if you go to the mathematics behind this algorithm, the algorithm that is used here is expectation maximization. So the if step is where expectation part is done, where the probability density is calculated by estimating the values of mean and covariance. So what you do is that based we use certain AIC and BIC criteria to find out the number of clusters. And once we get the number of clusters, we calculate the probability density. And then posterior probability is calculated. Now the M step is the maximization step, where for each cluster the mean and variance values are updated, and the learning parameters are updated based on the convergence criteria that we provide. And if you see on the right and on the left, you see there are the cluster assignments are going on. Now on the right hand side, we have given in this plot k equals to 4, so 4 number of clusters, and we see based on number of iterations from 1 to around 35 in number how the assignment changes. Now this is the result of the Gaussian mixture model. So what it is telling us is that most of the leads, which is 40 in number, 40 for our current problem statement, they reside in cluster 3, 12, and also partially in 1, 5, and 14. So that means on cluster 3, 40% of leads, so 40% of 40 in number reside in cluster 3. In cluster 12, close to 33% of 40 reside in cluster 12. And similarly, around 12.5% of lead population of 40 reside in cluster 5. Now what we can do is that based on this information, the unknown population that we have on cluster 3 and cluster 12, and also if we want more number of customers, we can also take in account cluster 5. Based on the probabilistic value that we get from Gaussian mixture model, we can give a rank order list of the unknown customers who are very similar to the lead population that are there in cluster 3, 12, and 5. And this is a rank scored list that we can provide to the marketing team. This is one of the plot to visualize different dimensions in a multi-dimensional space. So what it is telling us is that the different segments of clusters like cluster 3, 5, 12, etc., the different features are slightly how they vary. Now if you see in cluster 12, the RBA value, so RBA is the rentable building area, and this is the mean distance from the cluster centroid is more in cluster 12. The total taxes, the mean distance from the cluster centroid is also more, and how it varies across the different segments of clusters. If you see the star rating, so star rating is the less the star rating, the less efficient the building is. And if you see on cluster 1, you see that percentage household income earning more than $200,000, the mean distance from the cluster centroid is more for that particular case. So what it is saying is that this is the way to visualize in a multi-dimensional space how these different features are different across different clusters. This is not exactly similar to the feature importance that we get from classification model. It's more about segmenting different clusters. So to summarize what I discussed today is I discussed how an unsupervised machine learning approach called Gaussian mixture model can be used to, in a business problem, and the business problem is to acquire new customers. I have used third-party data sources since we do not have much information about those customers, CoStar and macroeconomic indicators, and later on I can also use Pitney Bowes and Dun & Bradstreet and other third-party sources. I talked a little bit about the Gaussian mixture model and k-means clustering, how they differ each other, and how the Gaussian mixture model works. And then I also showed visualization and 2 plots how the results of Gaussian mixture model can be used to give a ranked scored list to the marketing team. So this is all I had. I want to thank my team and co-workers at Duke Energy. I want to thank Rework organizers for giving me this opportunity to talk at this virtual conference. And these are my contact details. My email is my first name @gmail.com. firstname@gmail.com, and you can also find me on LinkedIn. So this is all I had. Thank you very much. If anyone has any questions, I would like to discuss, and if anyone wants to contribute and collaborate more in machine learning problems in your area, or if you think I want to improve in my area, please let me know. I would be happy to talk and collaborate. Thank you very much.